Startup Challenge. We think of it as a platform for catalyzing open defense innovation and co-creation. Okay? Co-creation between startups, innovators, researchers, MSMEs, directly with the defense services. That's the co-creation we're talking about. We've had some understanding of why we need co-creation. We've looked at some of the co-creation models that have worked in different parts of the world. We've studied how that has worked. We have some experiences doing co-creation in another context, which we will talk about. But most importantly, I'm going to set the stage to hear your views and your opinions. Right? So, in other sense, I'm like the waiter in a restaurant taking your order. Right? So, please be very free. And this is a restaurant where anything is available. Right? Feel as imaginative, as creative as you want to be, and tell us what you want, because ultimately for this co-creation to work and for us to be the facilitators, we have to understand both sides of the equation. Right? So today is my effort, my team's effort to understand the defense side, and then hopefully we already understand what the startups want, usually because we work with them in several contexts for several years, several experiences, so maybe we can bring it all together. In terms of the agenda, what I will quickly go through is why incubation. You have to understand why Forge, right? Why incubation? That sets the context for a lot of discussions to follow. Why open defense innovation? Why do we need this open defense innovation model? The background, the rationale to it. We'll then look at what kind of models has worked. So we'll take some case studies. We'll present that. We'll also look at how capable and ready is the Indian startup ecosystem for open innovation. And there are some contexts where it has already worked, so we'll talk about that. And talk about our vision and roadmap for DISC. And lastly, leave the floor open for each of you to come and share your views, your opinions, and we'll make it very interactive. Is that okay? Yeah. All right. So Forge, we call it a 360-degree incubation enterprise. Right? There are three words that need to be understood. One is 360 degrees, which is reasonably obvious, anything and everything. Right? Enterprise is, we're a company ourselves. Right? We believe and operate with a vision, with a strategy that we are a company, we are an enterprise ourselves. So we're not a department in an institution. We're not an NGO. Right? We are here to last forever. Right? We've started small. Hopefully, we'll expand more and more. We might have more branches. We might start doing more and more, impactful work. We want to scale up. But hopefully, this is an enterprise that's built to last. Right? That's the enterprise angle to it. Then comes the word incubation. Right? So, why incubation? Let's understand that. The way we look at the why incubation is to catalyze innovations and to create high growth enterprises. Now, why do innovations have to be catalyzed? It is because there is a lot of requirements, resources, expertise, skills, competencies, access to markets, access to early adopters. A lot of factors have to fall in place for an idea to just come out of somebody's mind and get translated into a working prototype that gets deployed, that gets tested. A lot of things have to happen. Usually, there isn't enough innovation happening out there. So this is basically from the point of view of, can we have more innovations first? Then can we have more quality innovations? That's next. So we believe in aim for quality, aim for quantity, quality will take care of itself. Right? So if you take a funnel approach, right? This is about flaring the front end of the funnel to see as many more ideas and innovations go through. Because in that, the system starts learning and the ecosystem starts throwing out better and better innovators. Right? So if you take the very famed Silicon Valley, San Francisco, US, California, right? Today we're talking about a ratio of 3 out of every 10 startups gets to $1 million in revenues or valuations. That number wasn't 20 years back. It was possibly 0.3, right? But something happened for that number, for that conversion, for that quantity and the quality to get to where it is. That's catalyzing. right? But catalyzing these innovations to what end? What do we want out of that? We want to create high growth enterprises. Now this word high growth naturally is the most important word of this. So why is this high growth needed? Now that's when all of us in the ecosystem can make money, right? For us as incubators, we make money when we give our services and resources at subsidized cost or even free to these innovators against equity, right? We take a small holding in the company. And when that company becomes a high growth enterprise, when that startup becomes a high growth enterprise, and when they get bought out for $1 billion, we get a chunk of that. Now this is not for profit. It's a Section 8 company, which means money can only go in, it can't go out, right? So if we have one successful exit in any of these innovator startups that we invest in or even support, when they make it big, we make it likely big. And that money gets put back into the system so we can have more innovators, more startups, more equipment, more tools. So that's why all of us need high growth enterprises. Why high growth enterprises? More jobs, more wealth in the economy, right? And naturally, more people will come into this innovation and entrepreneurship. Now, the number of engineers we throw out only in the state of Tamil Nadu is almost, I think, 10 lakhs a year. Right? There aren't 10 lakh jobs. The large, even the MSME sector cannot create as many jobs as the startups can. So if we support a startup and if it grows to 1,000 jobs in 5 years, that's 1,000 jobs created. And for that to happen, it has to be a high growth enterprise, right? And for investors who back these startups as angel investors, as VCs, for them to make it big, you need to have a high growth enterprise. Now, this is what we call the startup, as a journey, right? So we think of the startup as a journey from, I have this innovative idea, right? It might have come during my shower in the morning, right? I might have seen a problem, right? For example, those two girls that we saw. One of them actually has encountered that problem in her own life. Her uncle succumbed to a recurring, stroke. Right? So, and she, as an engineer, is saying, okay, now how do I go about solving that problem so that others don't end up facing that problem? So it starts there, right? And we're expecting that to become a high growth enterprise, right? And we use this word journey, right? Now this looks like a big leap. This is like a big leap of faith. This is when all the madness and magic sets in. This is when we celebrate entrepreneurs as mavericks. Because we assume that they've just done this leap, which not every one of us can manage. We give them that superstar status and we ask them to wear the underwear outside. Superman. Right? But actually, that's not how it works. What actually works is a process. It's not a journey. It's not a journey, a leap from idea to an enterprise. It's actually a process. It's a systematic, structured, sequential, stage-by-stage process. So it goes from an idea to a prototype, right? Where you have, what we call a 100% HCF product, which means no matter who the customer is, I have a product. No start selling it, right? Then you're able to generate revenues and you're able to move towards a path to predictable profits. That picture basically indicates light at the end of the tunnel, right? Which means I'm able to see a path towards profitability of this business. And I don't have, just like I don't have to reach the end of the tunnel to feel safe. I start feeling safe as soon as I see the light at the end of the tunnel. I don't have to wait to hit profitability. I can start thinking about growth, right? So we start expanding our revenues at a growth rate in excess of the rate at which the cost grows. And that's what we call a high growth enterprise, right? So this is the journey. It's the process that matters to make this journey happen. Now, what we do in Forge is manage this process, this managed incubation process. So we take innovators who come with ideas at this stage, and then we accelerate this process so they go out as high growth enterprises. Right? Now, doing this needs a lot of inputs, a lot of factors. Right? You need the means, right? Which could be the co-working facilities, which could be the innovation labs. We need that, right? We need the methods, right? The skills, the competencies that you need as an innovator, as a designer, as an entrepreneur. You need to know the skills and competencies to go sell your product in the market. You need to know how to plan your target market, how you go about planning your business model and executing the business model. That needs method. Next is mentoring, which is most important, right? This could be mentoring in terms of at a technology level, it could be at a innovation and design level, it could be at a product business level, it could be at a marketing sales level, it could be at the level of how do you raise investments for this business, right? Across the spectrum, you need mentoring to be able to fast track this process, because entrepreneurship is not about becoming a master of all the trades. Entrepreneurship is about bringing things together and creating value. So you don't have to be the expert in every aspect of your business or your technology or your product, right? And you can't wait, the world can't wait for you to become the all-in-all expert, right? Mentoring. Next is most importantly the market, right? So when we talk about market, what we, in the context of incubation, what we focus is on the early adopters, right? These are those target customers who can't wait to have that problem solved, right? And in that case, there is no risk because the guy is waiting. He says, come solve this problem for me. I'll even help you do that. I'll co-create with you. I'll collaborate with you. For an innovator, finding those early adopters usually ends up the biggest challenge, and usually the biggest reason why they fail, because they end up just building, thinking the world will come, but that does not happen. So connecting these innovators to the early adopters market, that's a very important factor to this process. The last is money, right? And there is a reason why we in Forge firmly believe that money is last. It's needed, but in many cases, if these 4 M's are provided, a lot of the money can be substituted, right? By the means of our expertise, resources, and other tools and infrastructures we have to offer. Now, what is available in the 4 walls of Forge, or what is available in the broader ecosystem, by bringing all of that, we can substitute a lot of what otherwise you need money for. So in that case, think about a startup entrepreneur who's achieved success with much less dilution of his company's stake. That's making him successful, right? That's like taking him to a valuation of 20 crores, where he still holds 80% of the company, as opposed to holding 10% or 20% or 30% of the company. And why did he dilute all of that stake? Because he wanted money to reach that milestone, right? So we think in these terms. So we call it the 5 M's of managed incubation, right? Means, method, mentoring, market, money. I'm going to take a quick segue into introducing myself, and I think this is the right context to do that, right? So what qualifies me to do this job, right? I've seen multiple cycles of this process myself, right? I've worked with at least 30 of these startups who've gone through this cycle as a joint CEO, co-founded 2 of my own, right? And in many cases, Forge is also attempting this journey, right? I'm an engineer by qualification only, right? Not by practice or experience. So I graduated with a degree in electronics and communication from CEG Chennai in 2000. Worked with Cisco, Nortel, Ericsson for about 8 years in the global telecommunications sector, everything from technical sales, marketing, business development, sales, business planning, business strategy. Did that for about 8 years. And then in 2008 to 2010, I did my MBA from IIM Bangalore. And during my MBA, I started working with startups from 2008 onwards, when Flipkart was 8 months old, right? When Myntra was just a concept on the paper, right? When many of those startups that we celebrate today didn't exist. Redbus was about a few months old, right? So I worked with most of these startups at the very early stage, and then the last 10 years I've been involved only with startups, right? And I've done work with a lot of these corporations, Infosys, Wipro, ThoughtWorks, and others, to help them put new products out in the market. So we know this process, how it works, right? And
me and several others like me who support Forge as experts, as mentors, come together to implement this process. Let's move on to the core topic of today, defense. And we're talking about these two words, technologies, innovation. Now, these two words are not strangers to defense. In fact, defense gave these words to humanity. Right? It's the military which has been the reservoir for the greatest of technologies that came out of mankind. And I'm not talking the last 100 years. Right? Let's go back in time to the Sumerian civilization. Right? When that civilization, when that clan head wanted to protect this kingdom, he came up with some innovations of weaponry. And whatever was those days' greatest and latest technologies, they were applied in the context of protecting that country or that society from the alien threat. So we're talking 5,000 years of defense, doing innovation, doing technologies, breakthrough technologies, right? And the particular case study that I wanted to talk about today is DARPA, right? The US Defense Research, Advanced Research Projects Agency, right? And I'm just going to flip to I'm going to stand here and actually do this. So this basically is on the DARPA website, and it presents the timeline of the technologies, innovations that have come out of DARPA, right? So you can see on this everything from the GPS to the laser to the personal computer to Ethernet, and then Internet, right? All kinds of things, right? So if you go through this timeline from here all the way, you will see generations after generations of products, technologies which have come out of defense. But as I move down this timeline, a few things strike me. One, in the 50s until the 70s and the 80s, some of these technologies, defense was the only entity on the earth doing that. Right? But that has changed. As I move into the 2000s and into the current situation, I start seeing technologies which are not only broken through, but deeply commercialized by the corporate sector, the private sector, the industry. Right? And research institutions are far ahead on their own independent, both applied as well as fundamental research. And defense is seen as an application, not a reservoir from where those technologies or products came from. Right? This is one thing that strikes me. Right? And I just wanted to, in that context, flip to looking at this slide that I found from a study on DARPA. Right? So they talk about how this used to be the approach of DARPA maybe a few decades ago. Right? So this is an individual investigator usually referred to as the program manager. Right? They basically look at, okay, what are all the needs, our current needs from a defense standpoint. They look at what are all the gaps in the technologies, and then they go about building incremental innovations. Right? This worked when the only team on the earth which was working on those technologies, researching on those technologies, was DARPA funded. And DARPA was never a lab. DARPA was more like a VC. Right? DARPA basically said, you know what, I'm calling out these projects. You could be Carnegie Mellon, you could be Stanford, you could be MIT, you could be whoever, apply. You could also be an industry R&D lab. You can apply, and if you qualify with a good proposal, we'll fund you. Right? This is the model that they did. Now this worked really well as long as the technology leadership, the thought leadership came from defense. And they talked about how this was changed to this approach, where you're basically looking at, okay, now what's already available out there? Right? What technologies are already out there? Right? So today in the context of, let's say, nano computing. Right? Nanocomputing is being taken up by the pharmaceutical industry at least for the last 10 years, 20 years. Right? You're looking at biological computing. Right? Lots of different technologies which have seen multiple generations outside of defense. So now the approach will have to start from, okay, what are the possibilities out there? Right? What are the gaps that we have? Now, how do we bridge those gaps? And in that context, the defense personnel and the researcher or the technologist or the lab who have the IP, can't be separated. They have to work together. So that sets up the context for co-creation. And in fact, DARPA, even in the traditional approach, was very direct interaction between the DARPA program managers, backed by defense officers, and with the research laboratories and the researchers. It wasn't separated in multiple layers. Right? So that co-creation was the hallmark from which breakthrough defense technologies and products came from DARPA. This is another snapshot I've taken from the DARPA website. Right? And it talks about DARPA's success depends on the vibrant ecosystem of innovation within the agency operates and is fueled by partners in multiple sectors. So they tend to believe that what drives success within defense innovation is this ecosystem. And this ecosystem is far and wide, right? So it talks about universities, it talks about industry, it talks about small business. In our context, that's startups or MSMEs, right? Government and so on. And this is the second scroll on the DARPA's website. So it's not deeply embedded in some vision statement or some about this page. It's just the second scroll of the homepage. This is another slide I picked up. So this is one particular project, direct methanol fuel cell program, which is part of by DARPA, and it shows about the different entities in action. Right? So this is co-creation at work. So naturally there is a division of areas between who has to work on what. I'm sure there's some kind of a integration roadmap. At what point do we come together? At what point do we diverge? At what point do we converge? Maybe there are some reviews done on what will carry forward, what will be dropped. Of course, there's a lot of program management work at play at a very technical level, at a commercial level, and so on. But it works as an ecosystem. Hacking for Defense is an initiative which is very successfully piloted in the US, and it works with universities. So this is founded by a person called Steve Black, who's a serial tech entrepreneur. He's the kind of guy that has made billions out of putting startups out into the market, raising billions of dollars, and ending up selling or making an IPO out of those startups, making loads of money, or ending up getting that company acquired by an IBM or a Microsoft or whatever. Right? He's done multiple rounds of that. So he's called the father of modern entrepreneurship, Steve Black. Right? Now Steve Black, he picked up a lot of, so he believes in, so all of us are students of Steve Black in that sense, right? So we believe in the process of, or a structured process of going from innovation to an enterprise. So he's brought some of that thinking into how you can hack for defense. And this program, Hacking for Defense, is run as a course in Stanford. Right? And that's actually an elective course. 297 is an elective course, right? So this course is a 10-12 week course. And in this course, students in teams of 4 or 5 work on specific challenges given by defense through DARPA or otherwise. And they end up working directly with those defense personnel, people like you. And in those 12-week timeline, they come out with a working program. So this is rapid innovation in action. Certainly not all of them are going to see the light today in terms of getting produced, mass-produced, and what you call inducted into defense. Not all of them, and that's not the goal. But this is to see, some of the brightest. This is Stanford, right? Some of the brightest, smartest students in America solving problems for the defense sector. And these are the guys who Google will queue up to interview, not the other way. Right? But before they graduate, they want to work on defense. They want to see if that can enhance their learning. I mean, it can't get more advanced and sophisticated than defense. If I can solve a defense problem, I should be right at that in terms of my skills, right? Can we play this video? It's about 2 minutes and 40 seconds. Is that okay? Can we play this video?
For defense is an academic course that combines the real-life problem-solving skills with real-life problems that we've extracted from the Department of Defense, the intelligence agencies, and largely the government. We came up with an educator's course that certifies structural teams. Today, 10 universities in the United States have taught this course.
Prototype class in Columbia picked it up and just nailed it incredibly, right? The Hacking for X program is essentially the same lean methodology applied to national service problems. We went out to first the U.S. Department of Defense and intelligence agencies and said, give us your toughest problems and we'll recruit the best and brightest students who are just hungry to work on things that are real and see if they put together teams and see if they can actually solve some of these challenges.
Hacking for Defense is designed to get students involved in helping to solve complex national security problems. Students, especially undergrads, learn from weight problems, and it was really nice, both for me and for the students, to get a chance to see how these things apply in practical scenarios and actually tackle real-world problems.
Students are just perfect for this is because they're intensely curious. They want to learn. The best and the brightest want to work on some of the toughest problems. Experiential education is probably the best way to kind of make something stick forever.
In the Hacking for Defense class, I finally felt like I was able to take on a real problem and develop a real solution that would be used in the real world. It felt like the work that I was doing inside of the classroom mattered for much more than just a grade. I definitely think our team felt the pressure to deliver something because we had buy-in from our sponsors that are making important decisions every day. There are real world consequences here, and you can also have real world impact and save lives.
We developed an app for the Android system. It's called CASTAC, so that's Casualty Triage and Communication. It helps streamline communication between medics on the field, team leaders, the headquarters, as well as incoming medics on the medevac helicopters. One of the most rewarding things to do is to feel like I had a hand in developing something tangible and real and that I could point to as a work product. It was completely different from my other coursework, but in a way that I really felt that I used a lot of the things that I've learned in the past couple of years to help me succeed.
Thank you.
So this is the website of Steve Black, the person behind this concept. And what we're seeing here is the Hacking for Defense Stanford 2018. This is just one of the many batches. So currently they're doing this at about 10, 12 different universities, colleges, different batches, so to speak. And this page actually has the entire sum up of all of those innovations, defense innovations that have happened in that in this particular batch. Right? So you go from so each team there is a video which talks about what their innovation is all about, right? And then their actual presentation on what is called a demo day, right? So there is a concept of a demonstration day, right? So at the end of the 12-week curriculum course, they invite the defense officials, right? The officers. They also invite industry. Right? They invite VCs, venture capitalists, investors, right? Because what is getting showcased is innovation. What is getting showcased is a technology breakthrough, an application of a breakthrough technology. And even if beyond the defense context, if there are people who are willing to look at it in the private sector, in the civilian sector, either a consumer sector or the industrial sector, why curtail that opportunity? Right? It's only going to add more value to that innovation pursuit. Right? So this, if you're interested, I can play one of them. Is that okay? Play one of them? Yeah. And we will take this.
New Military operations are increasingly defined through information flow and situational awareness. Events which remain non-automated require significant commitment of time in order to collect and process information. Special Operations Command asked our team to mitigate a shortfall in automated capabilities during helicopter evacuations. Teams infiltrate via aircraft, execute a mission, and return. During the course of an operation, the number of aircraft and people change, yet perfect accountability needs to exist. Current methods require deliberate comparison of printed rosters while in environments which degrade sight and hearing. Our first hypothesis was that automatically counting personnel loading helicopters would prevent SOCOM from leaving anyone behind. However, commercial systems are heavy and require operators to actively interact with the tool rather than performing mission-essential actions. Finally, SOCOM does not leave people behind. Our sponsor's pain point is not personnel accountability, but excessive time costs. Planning requires manual data entry and paper manifests to track changes. We observed SOCOM's planning and execution process to find time-saving opportunities throughout an operation. Our minimum viable product integrates manifest planning, modification, and version control with automatic mustering utilizing existing Android-based equipment. We designed an Android interface to automate repetitive tasks and integrate with ATAC situational awareness mapping software. We allow mission planners to modify shared manifests during the mission, improving capability while reducing time costs. Our custom transmitter musters personnel using received signal strength and a rotating identifier. Coordinates are never transmitted, the missions are user controllable, and the transmitter weighs 30 grams with a 6-month battery life. Using this system, a SOCOM team employs an automatically manifesting real-time representation of team member proximity to assign tactical team and aircraft, decreasing time costs in all phases of an operation, and during emergency evacuation, provides a rapid, actionable information flow while adding minimal equipment to the warfighter.
So what's the process at play? Right? We started this with saying this process of innovation is the structure equation. And what goes on in this Hacking for Defense course is this stage of activity. Right? So they involve very deeply with the defense personnel. They understand the, or in other words, the ideas of source. Right? And then they go through a problem curation process. Right? And in this process, it's direct. It's not removed. Right? It's not a challenge statement which is put out, and offline there is some ideation that happens. This process is as direct. So we talk in terms of get out of the classroom, get out of the lab, and actually go and talk to the the defense beneficiary, right, and get that perspective, right, and followed by a prioritization exercise. So which of these problems are worth solving? Which of these solutions or ideas make sense? Could there be a criteria? Right? Actually, that process can't be done by the researcher or by the students, but it needs to have complete involvement of the defense personnel as well. Right? And then look at this process of hypothesis, what he calls hypothesis testing. Right? This is prototype, right? And then you go through an extended process of incubation, where you actually go through the design, development, deployment, testing, system certification, trials, all of that, and you're now ready for next commercial production. Right? So this process is what we have adopted in large ways. So we showed you what's happening with the Innovation Fellowship program that we are doing. Right? In fact, all of these innovations have an animation video, much like the video that you saw. Right? Because it's very easy to and very effective to communicate an innovative idea visually. I don't need the person to actually come and present for 10 minutes. Can there be a 1-minute video that very precisely, concisely captures the core of your innovative idea, either at a benefits value proposition level or in terms of how you build that value proposition, the product technology level, that can be captured. And we in Forge follow most of these principles. We have our own set of what are called I-tools, innovation tools. Right? So the way we take a problem statement, a challenge from, let's say, the industry, and then how do we sort of immerse into that problem statement? How do we define it? How do we describe it? How do we understand what are the other constraints that have to be kept in mind when you go about solving that problem? right? We do it very rigorously, right? And then there are different tools, there are different what we call canvases, right? Which help in this process of ideation, right? And through this process, we're able to refine the idea, we're able to refine the problem statement, we're able to understand exactly what is needed and what is not needed. So as opposed to building the whole thing and then going into trials, at every stage can you look at, is this making sense? Is that feature making sense? Should it be done this way or should it be done that way? Right? At every stage, if we involve the end user, then the innovation is not risky, you're not wasting. Right? So we talk in terms of technical debt. So any feature, functionality, technology that's put into your innovation that gets unused is dead. So the question is, who did you build it for? Right? Because it turns out nobody wants to use it. That's wasted money, wasted effort, wasted time. Right? So this is sort of the background. Now, with this in mind, right, what we've basically come up with is a set of what we believe are key success factors for this open defense innovation to become successful, right? So the first one, and the most important, the voice of soldier. So when we talk about innovations for consumers, when we talk about innovations for the industry, we talk about voice of customer, right? Because that's the only thing that matters. So for example, what we mean by voice of customer? We'd like to define the problem statement the way it is experienced by the target customer. Because if I were to watch somebody encounter, experience that problem statement and then for me to describe it, it is not going to be the same as it comes out of that person's mouth. Right? And yesterday we were talking to about why this is very important. Right? So when we talk about, for example, each of these 11 challenges in front of us, right? We may be able to look at it from a technology point of view, from a efficiency point of view, or from a product specification point of view. What we will never be able to understand is the soldier's perspective. For obvious reasons. Right? That I think is fundamental to this exercise of co-creation. Bring the voice of soldier. Right? Come on. Second, the innovation process and this pipeline which I showed you. Right? So there is a process, it has rigor, it has structure, and it goes through a sequential step-by-step, one after the other. That we believe can bring more confidence on the defense side. Because what we don't want you to think about is, is this being done for fun? Right? Is there any sense of metric? Is there any sense of reporting? Is there something that will come back? Even after I've spent a few hours to engage with these innovators, what will I get back from this exercise? But I will just get a document, right? So to analyze some of those fears and some of those apprehensions, we believe in the process. We believe a process can have a lot more outcome than just the person. Of course, it is the innovator or the group of persons who are mostly the reason why this will become successful. But if you take the process out, then we tend to believe that it's not efficient, it's not effective. Right? And then the other one is pipeline. Right? Is about having ideas at different stages. Right? So how many of these are at challenge statement level? How many of them have progressed to a next level of problem curation, challenge curation? How many of them have gone into next level of some kind of a prototype definition or scope definition? How many of them are getting into actual design and development? Right? So you want to see this as a pipeline. So what we'd like to present to you is, here are the challenges, here are the innovations at play, they are at different stages. Why this helps is, let's say you want to pull one out of stage number 2, bump up its priority and push it, you can do that. Because you know what is happening well. It's almost like an assembly line in that sense. Right? So we want to put that focus into process as well as the pipeline. Next is a portfolio model. Right? When we say portfolio model, think about how investors go about managing their stock portfolio. They don't just bet on one. Right? And some of you understand the science behind portfolio theory. right? When I deal with 30 stocks as opposed to one stock, in and of itself, the risk with those 30 stocks is cross-correlated, and therefore the overall risk is low. Right? That's the portfolio model that we believe will become successful. So if let's say if it's Army, right? If it's Navy, it's Air Force separately, or if it's BEL or BEML separately, and if these are the kind of needs you're looking at, right? Can we look at a portfolio model as opposed to going one after the other? And this is actually something which we've studied from the DARPA model, right? And just so you know, we will share all of those materials that we have access to in soft copies as well as in hard copies. Just give us some time to try to make sure that it's all put in a reasonably easy to understand format, and we'll give it to you. The next one is the ecosystem. Well, this can't be emphasized. Right? It is this coming together of many diverse stakeholders that's going to make this process very effective and very successful. Naturally, co-creation. Right? How do we co-create? How do we bring all of these things together? Now we've sort of covered these, I would hope. We looked at why integration, we looked at why open defense innovation, why co-creation, we looked at what has worked, what have we learned from. At this point, I just want to talk about how capable and ready is the Indian startup ecosystem. So there is another context in which this co-creation is working today, and that's for large corporations. For example, as we speak, we work with Bosch, the German multinational, right? We're helping them put together a cohort of 20 startups under this very broad theme called Connected Life, right? And we have helped them bring together these 20 startups. They're geographically dispersed across the country. They could be different technologies. They could be blockchain, they could be IoT, they could be robotics, they could be in electric vehicles, they could be autonomous vehicles, they could be across the length and breadth of the technology spectrum. We bring them together and we take them through a 16-week incubation process. The idea being that at the end of the 16 weeks, they are aligned with the strategic business interests of Bosch. So in this 16-week period, there's going to be a healthy exchange of ideas and expectations between the Bosch business heads and these 20 startups, and we play the facilitator role. Right? So what kind of technologies do we prioritize? Right? What kind of downstream models do we look at? There are different ways in which this marriage can happen, so to speak. Right? For example, Bosch might say, you know what, that's an excellent team. That team of 5 professionals are very good. We're going to hire them as employees. So we've given it a very glorified name in the startup world. We call it acqui-hire. Right? And we usually say acqui-hire for an undisclosed amount of money. Just to make it sound that those are bucket loads of money, which usually is not. It's just like 1 month's salary. Right? Or we think in terms of, okay, fine, the product is good, I'll put the Bosch chapa on it, and I'm going to sell it through my global distribution and retail system, because Bosch can now sell to any country in the world. For the startup, you'll have to rebuild that distribution network. Now that doesn't make sense. Right? So we call it a commercial integration or a commercial partner. It could be another case where, you know what, the technology is awesome, but we'd like for ourselves to commercialize it or productize it differently. So can we do a technology licensing? So we buy out the IP for a certain amount of money, and then we go about productizing it as Bosch. Right? Or it could be what is called a strategic investment, which is we pick up a certain stake in the startup, we keep it at arm's length, and that's more important, right? Because this organism, this Bosch, has a very high immunity level, and this DNA will kill that virus when that startup comes closer. Because the immunity level inside a host is very high. And in case you realize, when we do an organ transplant or surgery, the first big thing the doctor does is reduce the immunity level of the body down to the barest level, and then start the organ transplant. Otherwise, the surgery will be a failure because the immunity of the system will reject the organ being transplanted. So and that's the work we have to do with Bosch. Say, you know what, don't set your expectations so high. Right? Yeah, we get it. You're German and you're Bosch, we get it. Yeah, but keep it low. Right? Let this get into the market and see what can come out of it. Right? So these are already things that are happening. So I'm just kind of talking to you about what is already working in the Indian startup ecosystem. Right? So today we're talking about GE, we're talking about Bosch, we're talking about Honeywell, Siemens, we're talking about Lockheed Martin, we're talking about United Technologies, we're talking about several defense sector contractors also engaging directly with these startups, with the innovators and co-creating. And whatever we have in terms of the know-how, the process, the tools, all of that is something that we can bring to the table when we serve as partner incubators. So the way we have looked at this roadmap in terms of facilitating this open defense innovation, we look at 4 stages. This is what we have come up with, and this is where I need a lot of your inputs and opinions and guidance and so on. So the first step is the discovery process. Right? So here we're talking in terms of what are the gaps that you have in terms of what is available today. Right? It could be a product functionality feature gap. It could be an import substitution need. It could be a technology that you want to pilot and experiment and explore. We'd like to understand those things. One of the important events that will happen in this stage is the hackathon. Right? So for example, we did a 5-day hackathon for the MHRD for students, where in 5 days they were here and they created a working prototype of some industrial or consumer grade products. We'd like to arrange for those kinds of things. Right? So prior to the hackathon, a lot of these challenges can be broken down into specifications. And during the hackathon, we can not only see how these can be prototyped, we also can test the skills of those innovators. So some selection and some elimination can also happen in this stage. And that would end with innovation, so many innovation proposals which are being considered for a grant. And that's what starts with here, right? So as part of the DISC initiative, the Department of Defense Production has announced a grant of up to 1.5 crores for each of these proposals for these 11 challenges which will get approved. And our goal is to basically manage that process of grant disbursement. So the money will go from DODP directly to the startups, the innovators. We will make sure that the milestones are defined, the milestones are tracked, the report is sent, and making sure that the money is spent frugally, effectively, and economically. That will then translate into rapid prototyping, joint design reviews where the co-creation will have to be very high, and then getting into defining the systems integration specifications, what are the trials and acceptance criteria, and most importantly, here look at what are all the resources capacity that is available within the defense sector, whether it is BEL, whether it is BEML, whether it is PDL, what can be brought to the support of these innovators to fast track this process of design. All of those will go into this stage. The last one is demonstration and deployment. Right? So here we are basically talking about how do you get access to test sites. Is it needed? Right? Or is this something which the respective services headquarters can do and send feedback back to the innovators? Right? So we'd like, maybe this could be on a case by case basis, right? So some of those things being confidential and all restricted. We'll have to work through that. This process would typically end at a stage where it's ready for production. So at that stage, are we doing a technology transfer to an existing defense empaneled MSME, or are we doing it to the DPSUs, or are we going to invest, get external funding? A VC comes in funds and says, you know what, I'm going to support that startup, let them get into independent production because it has beyond military applications as well. Right? So this is how we've looked at these 3 stages, and keeping in mind that it's going to be highly competitive, right? It's a collaboration, right? And there is going to be a lot of convergence in terms of making sure that the sum or total is greater than the sum of parts.